Good morning, students. Today I will be explaining about the parallel combination of resistance. So, when two or more resistances are connected between two common points so that the same potential difference is applied across each of them, they are said to be connected in parallel. So let me explain this statement with the help of this diagram. Now in this diagram there are two resistors R1 and R2 and they are connected to the endpoints A and B. Now this A and B are the common endpoints. So the connection of R1 and R2 will be considered as a parallel connection, because both of them are going to have the same common points A and B. If you look at the diagram here, I is the main current which is divided into branches I1 and I2. So we can say that I is equal to I1 plus I2. Now on the basis of this, the properties of parallel combination are: number one, in parallel combination, the total current is divided into branches according to the resistors connected to the branches. That means, if we talk about the figure here, R1 and R2, the current has been divided into I1 and I2, and these two currents depends upon the value of R1 and R2. The second point is the potential difference between all the resistors connected in parallel will be same. It means that both the resistors R1 and R2 will have the same potential difference, or you can say the same voltage. So in parallel combinations, we have got two properties. The current will be divided into branches and all the resistors will have the same potential. Now on the basis of that, we are going to derive the formula of parallel combination. Now if we look at the diagram here I is the main current and there are three resistors R1, R2 and R3. Now the main current has been divided into three branches I1, I2 and I3. Now these three resistors are connected in parallel because all these three resistors are going to share the same common points A and B. So regarding the derivation, I1 will be equal to V by R1, I2 equal to V by R2 and I3 is equal to V by R3. That means I1 is the current of this branch, I2 is the current of this branch and I3 is the current of this branch. And we can get the values of I1, I2, I3 by these formula. Now suppose we replace all these three resistors by a single resistor R, which is known as the equivalent resistance between A and B. Then the total current I will be passing through this resistor R. So if R is the equivalent resistance, then by Ohm's law, the total current flowing through the circuit is given by I is equal to V by R. Now as we are knowing, the total current has been divided into three parts, I1, I2, I3. So look at the diagram here. The total current has been divided into three parts, I1, I2 and I3. So we are now going to put the values of all these I1, I2 and I3, and on the basis of that we are going to get the formula V by R is equal to V by R1 plus V by R2 plus V by R3. Now if we take out the V common and we cancel out the V from all those expressions, then we are going to get the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now this is the formula for parallel combination of three resistors. Now if you look at the derivations one more, we have first found out the value of I1, I2, I3 with the whole help of the Ohm's law. Then we have found the value of the total current I, which is passing through the resistor R. This is the equivalent resistors R. Then the total current has been divided into three parts. After putting the values of the three parts, we are going to get this equation. Now coming to the general formula, we can say 1 by R is equal to 1 by R1 plus 1 by R2 plus ... 1 by Rn. It means that if we connect more than 3 or 4 resistors in parallel, we have to follow this pattern to find out the equivalent resistance. Now coming to the summary of the parallel combination, we have got 3 points to be summarized. Point number 1. The current flowing through each resistor is inversely proportional to its resistance. That means higher the resistance of a resistor, lower will be the current flowing through it. That means if in a branch you put a resistance of high value, then in that branch the amount of current will be flowing will be less. That is the meaning of the point number 1. Point number 2 says the total current flowing through the circuit is equal to the sum of currents flowing through each resistor. That means the total current I will be equal to I1 plus I2 plus I3. That means the total current will be divided into different branches. Coming to the third point, in parallel combination of resistors, the voltage across each resistor is same and is equal to the applied voltage. It means that since all the resistors are going to share the same common point, then the total voltage of each of them will be equal to the total voltage of the circuit. And that is the third point. So if you look at the first point, the total current will be inversely proportional to the value of the resistor. Second point says the total current will be divided into different branches. And the third point says that the voltage of each resistor will be equal to the total voltage applied to the circuit. Now coming to some important points. In parallel combination, the equivalent resistance is less than each of the individual resistance. This is a very important point, that whenever we connect the resistors in parallel, the equivalent resistance will have a value lesser than the value of each resistor. Point number 2 says in series combination, the equivalent resistance is more than each of the individual. That means the total resistance will be greater than the value of each resistors. On the basis of that, if we are coming to take up one example, so we are going to have an example here. We are taking two resistors, 3 ohm and 2 ohm. They are connected in parallel because they are going to share the same common points here. Look at the figure here. Both of them are going to share the same common point. So 3 ohm and 2 ohm are connected in parallel. So on the basis of the parallel combination, if we want to find out the equivalent resistance, the formula is 1 by Rp is equal to 1 by 3 plus 1 by 2. Solving, we will get 5 by 6. Now, this is the most important step here. We need to find the value of Rp. Therefore, we will go for the reciprocal of this answer. That is, Rp will be equal to 6 by 5, that is 1.2 ohm. So whenever you are solving any question of parallel combination, the most important thing is that after you found the value of 1 by Rp, you have to do the reciprocal of the answer to get the actual value of the equivalent resistors of a parallel combination. So whenever we get any diagram here, first we have to look at the diagram, whether they are connected in parallel or not. How to know that they are in parallel? By looking at the common points. So this is how we are going to solve the questions of parallel combination. So in the next class, I will be taking up some more numericals concerned with this topic. So thank you and have a nice day.